All right, the last part of this chapter is the classes of compounds. We're going to be talking about what's called functional groups. All right, you can call it classes of compounds, but most people call it what's called a functional group. I'm sure you'll see this word in the book as well. Functional group is basically a set of atoms on a molecule that gives it its function or specific properties to the compound. Okay, I'm going to give you a perfect example. There's two compounds that are very similar. Okay, here is this one. I'm going to write them out here, CH3, CH2OH. And then there's another one, CH3, C double bond O, OH. These have very similar properties. They both have hydrogen bondings. They have these OH groups. They have the same amount of carbons. They're almost the same mass. Okay, this compound is ethanol, okay, or ethyl alcohol. It's a type of alcohol. That's the class of compound it is, or the functional group is an alcohol. This is acetic acid. All right, it's a carboxylic acid. Acetic acid, another name is vinegar. Vinegar is actually a mixture of acetic acid and water. Okay, two compounds that people know something about. All right, ethanol is the drinking alcohol. All right, and acetic acid is vinegar. And you guys know that these two compounds are not even close to the same thing. All right, alcohol, usually, in a beer, on a whatever Friday, Saturday night, you go out for a beer or something or have a drink. All right, a glass of wine. Acetic acid, great on salads. All right, goes great on salad. A little bit of tang in your salads, no problem. But I would not want to take a shot of acetic acid. All right, there's just properties about it that I think would taste pretty gross if I took a shot of acetic acid. Nor would I want to put ethanol on my salad. All right, that is an issue, a big issue, if you put ethanol on your salads. All right, so just by changing, by removing these two hydrogens and putting in a double bond oxygen into it, you completely change the properties of the molecule. This is one reason why I even find organic chemistry fascinating. By just a slight change of the molecule, you completely change all the properties. So what I'm going to do is I'm going to go over all the classes of compounds that you need to know for this class. And I want you to start learning what these groups look like. We'll talk more about this in class, but I'll talk about it here on the slides. All right. So classes are based on functional groups. I just talked about that. There are three main classes. Hydrocarbons is the first one, which is just composed of carbons and hydrogens. There's ones that contain oxygens, and there's one that contain nitrogens. Now, some do have sulfur atoms in them, but we're not going to talk too much about them. Also, halogens. I'm going to add halogens here because that's the class of compounds that we're going to be talking about a lot. So, halogens. And these class of compounds are just called alkyl halides. Okay, and we will talk about these a little bit. Okay, so let's first talk about hydrocarbons. Very straightforward. Alkanes. That's the name of the class of compounds called alkanes. It ends in ANES. These are all single bond carbons to each other, and you have the maximum amount of hydrogens attached to it. Okay, these types of compounds, they basically burn. Like propane. Butane, octane. All right, that's basically it. Hydrocarbons, you can even have cyclical structures like that, like cyclohexane. All right, pretty straightforward, nothing too interesting about them. There we go, cycloalkanes, all sp3 carbons. All right, alkenes is the next class, and alkene has a double bond. So anytime you replace the A on alkanes to an E, you have an alkene. Alkenes has a double bond. You can have one double bond, two double bonds, 100 double bonds. It can also be in a cyclical compound, so it doesn't really matter. All right. The benzene ring is a special type of hydrocarbons called aromatic. I don't know if it's on these slides. Maybe it is, but an aromatic compound is another class of compound. That's very important to know. And those are these six-membered rings where you have alternating pi bonds because you have resonance inside of them. That's what makes it aromatic, is that resonance effect. So those are alkenes. Cycloalkenes, just talked about. Alkynes now is a triple bond. So if you have a triple bond, all right, you have an alkyne. Oh, and there you go, aromatic. They do have aromatic. So aromatic is another, like I talked about, just insert that into there. All right, those are aromatic compounds. So those are the hydrocarbons. know the structures. So if you see a compound that is all single bonds, that class of compound is called an alkane. If there's a double bond, it's an alkene. If it's a triple bond, it's an alkyne. If it's a ring with alternating double bonds and you can draw a resonance structure, then you have aromatic. Next are oxygen containing. These are the most common, especially in biological systems. You see tons of compounds have oxygen in them. Alcohols are probably one of the most popular. This contains a hydroxyl group, which is an OH group. So it's some sort of carbon that has an OH attached to it. Okay, and then all these other carbons are most likely carbons and hydrogens. Now, it could be single bonds, it could be double bonds, it could be triple bonds. Like, for example, maybe I can have a cyclical alkene with an OH group. All right, now, this has two functional groups on it. It's an alcohol and an alkene. Okay, so it's both. So just be aware you can obviously have more than one functional group. Next one are ethers. Ethers are very similar to alcohols, except you have two carbons flanking between your oxygen. Okay, here we have a carbon, oxygen, hydrogen. Here we have a carbon, oxygen, carbon. That's what makes an ether. I am going to show you a little joke, a little chemistry joke. I love chemistry jokes because they make you learn. So what do you think this is called? It doesn't look that great, but I tried my best. There we go. Put a little mouth there. That is called an ether bunny. I know you're laughing. It's okay. You can laugh. That's called an ether bunny. See the ether? And it looks like a little bunny, little whiskers. I guess these whiskers don't look that great. Should do more like that. Whatever. Okay. Anyways, the ether is a carbon with an oxygen and a carbon. Those are ethers. Aldehydes. So first of all, let's talk about C double bond O. C double bond O has a special name to it. It is called a carbonyl. Carbonyl. That group is called, but now that's not a functional group. Not a functional group. That is just the name of a C double bond O. Okay, aldehydes and ketones have a carbonyl in them. Carboxylic acids have a carbonyl in them. It's just part of the functional group. It's kind of like saying, I have a car. A car is the main name of it, but it has a steering wheel. So the steering wheel is the equivalent of a carbonyl, where the car is the type of aldehyde. If I have a truck, that's a ketone, but also has a steering wheel in it. Okay, so an aldehyde is a carbonyl that has a carbon on one side and a hydrogen on the other. So here's my carbonyl, and then a carbon is on one side and a hydrogen is on the other. That is an aldehyde. A ketone is a carbonyl, but you have a carbon on one side and another carbon on the other. Now, there's a special type of aldehyde called formaldehyde, which actually has two hydrogens. That's the only case where you have two hydrogens. Otherwise, you'll have a carbon and a hydrogen. Those are aldehydes. Two carbons with a carbonyl is a ketone. Okay? Carboxylic acids is a carbonyl with a carbon on one side and an OH group on the other. Okay, I'm not putting my lone pairs on all of them, but just know there are lone pairs. So aldehydes and ketones, all right, are, here's aldehyde, carbon, you have to have at least one hydrogen. Let's just put it that way, at least one hydrogen. You can have anything else on the other side. Well, as long as it's a carbon or hydrogen. And then you have two carbons is a ketone, a carbon, and an OH group is a carboxylic acid. This proton is very acidic. Why do you think that proton is very acidic? Why do you think it pops off easily? Remember we talked about acidity? We talked about the stability of the ion. Well, if that hydrogen pops out, you'll have a negative charge right here, and this ion is stabilized through resonance. So if this hydrogen pops off, you have a stable ion through resonance. Anytime you have a stable ion, your compound could be acidic. In this case, you do not have a stable ion. If you have a C negative right here, that's not very stable. It can't resonate. Remember, resonance is the atom that's next to the pi bond. Otherwise, you don't have stability. Nitrogen-containing compounds. There's lots of these. An amine, all right? Amines, they're basically a nitrogen with a carbon group on it. You can have one carbon group. That's called a primary amine. Two carbons on a nitrogen. It's called a secondary amine. Or three carbons and nitrogens. That is called a tertiary amine. Primary, secondary, tertiary. Kind of shorthands is primary, secondary, tertiary. Okay? If you do not have a carbon on it, if you just have all hydrogens, that compound is called ammonia. Okay, so it's basically an ammonia but with a carbon. That's why it's called an alkylated derivative of ammonia. Alkylated means it has some sort of carbon group on it. Okay, so that's an amine. Amides, let me erase this. So amides are like an amine, except it has a carbonyl group. All right, so it's an amide with a carbonyl group. So a carbonyl. On one side you have a carbon, and on the other side you have an sp3 hybridized nitrogen. Okay, and at these spots right here, I'm going to put parentheses. You can either have carbons or you can have hydrogens. So you can have a carbon-carbon, a hydrogen-hydrogen, or a carbon-hydrogen. You can have any combination of them, but you have to be next door to a carbonyl. All right, let me just show you. If you have a compound that has a carbonyl here and like a nitrogen way out here, this is not an amide. This is a compound that has a ketone. This is a ketone. Why is it a ketone? Carbonyl flanked between two carbons. And you have an amine. Why is it an amine? Because it's a sp3 nitrogen with a carbon on one side and two hydrogens here. Nitriles are C triple bond ends. That is a nitrile with a lone pair on it. And you have another carbon here. That's a nitrile, that group. All right, so that is the end of the slides. There are other functional groups. We will talk more about them when we are in class. But for right now, those are the main ones that I want you to start memorizing. And remember, remind me about that demo.